Hello my dear students. So I am going to discuss the exercise related to the 17th lesson of your grade 10 science textbook, that is rate of reactions. So in the previous chapters we discussed what rate of reaction is. What is it? The rate of change occurring during a chemical reaction, or the change occurred in a unit time. So that is the rate of reaction, and so that is equal to the rate at which reactants are consumed or the rate at which the products are formed. So related to that, we discussed the different factors: surface area, then temperature, concentration and catalyst that affect the rate of reaction. So that was the lesson, and now we will discuss the exercise. So I am sure students you have already answered these questions. If not, you all answer it by yourself first and then you can check your answers with my discussion. That will be more helpful for you all. Exercise. And the first question, what do you mean by the rate of a chemical reaction? So what do you mean by the rate of a chemical reaction? The change that occurs in a unit time during a chemical reaction. So we can say the change that occurs in a unit time during a chemical reaction is known as the rate of reaction. So if you are to give an equation, what can you say? The rate at which the reactants are used up or consumed, can say consumed, or the rate at which the products are formed. So this is how we calculate rate of reaction. You take the amount of reactants used up divided by time taken, you get the rate of reaction. Otherwise, you can take the amount of products formed and you divide it by time and you will get the rate of reaction. Whether it's the reactants being used up or products being formed, it is the same rate of reaction. Why? Because when the reactants are used up only, the products are formed. So that is why we call it as the change that occurs in a given time. Is that clear to you all? So what do you mean by the rate of a chemical reaction? This is what you can write. You can either just give this explanation or you can write the second one. I have written both to make it more clear to you all. If they ask you for the equation, you can give this in the equation form. I am sure you all can do that. So then, we will move on to the next question. Second one factor that affects the rate of reactions is the presence of catalyst. So you know what catalysts are. Substances that increase the rate of reaction without being chemically consumed during the reaction. So that is a catalyst and they increase the rate of reaction. One factor that increases the rate of reaction. State three other factors that affect the rate of reactions. What are the other three factors? You can remember, one is temperature, then the next one is concentration. When we say concentration, we specify pressure for gaseous reactants. So pressure of gaseous reactants, but otherwise we say it as concentration. And also there is the surface area, or what we say as physical nature. So you all know how they affect the rate of reaction. When temperature increases, rate of reaction increases. Temperature decreases, rate of reaction decreases. Concentration increases also, the rate of reaction increases. If it is pressure, you decrease the volume of the container, the pressure increases and the rate of reaction increases. And surface area, when you have it as a solid chunk of substance reactant, then the surface area is less. When you make it into powder, then the surface area increases. Or if it is a long strip, if you break it into tiny pieces, again the surface area increases. So either way, when surface area increases, that is by changing the physical nature, then you can increase the rate of reaction. So I am sure you all can remember all these and you have written all the answers correctly. With that, students, we'll move on to the next question. Question number 3. Briefly explain how each factor you stated above changes the rate of a reaction. So we stated 3 factors: temperature, concentration and surface area. So the 3 factors, how they affect the rate of reaction. So since I have written it in that order, I will use the same order here. So the first one I wrote was temperature. Now temperature, how does it affect? When temperature increases, the rate of reaction increases. So when temperature decreases, the rate of reaction decreases. We don't have to write that again. Now how can we explain this? You all can remember. We provide heat energy to increase the temperature. So then what happens there? The kinetic energy of reactant particles increases. Because of that, they move faster and therefore there will be more number of collisions in a unit time. And because of that, their rate of reaction will increase. That is what you need to explain. Briefly explain how each factor you stated above changes the rate of reaction. So here if we are to explain, we can say when temperature increases, the kinetic energy of reactant particles when temperature increases, the kinetic energy of reactant particles increases. Therefore, the number of collisions in a unit time increases. That is why the rate of reaction increases. So, first factor is temperature. When temperature increases, the rate of reaction increases. And when temperature increases, the kinetic energy of reactant particles increases. Therefore, the number of collisions in a unit time increases, and that is why the rate of reaction increases. So, that is something you can remember, students. So that is the first factor we wrote for the previous answer. What was the second one? We considered the concentration. So then also we need to write this. Second one is concentration. Now concentration. How does this affect the rate of reaction? When the concentration of reactants increases, the rate of reaction increases. We need to give that as well. So when concentration of reactants increase, the rate of reaction increases. So here also, students, it's understood that when the concentration of reactants decreases, the rate of reaction will decrease. So you have to remember that. So how does this happen? When we say concentration increases, what happens there? The number of reactants in a unit volume increases. So because of that, the number of collisions in a unit time increases, and therefore the rate of reaction increases. So that is what you have to explain here. You can say when the concentration increases, the number of reactants in a unit volume increases, then the number of collisions in a unit time, or you can say per unit time, increases. Thus, the rate of reaction increases. So when the concentration increases, the number of reactants in a unit volume increase, then the number of collisions in a unit time increases, thus the rate of reaction increases. So that is the second factor we gave for the previous answer. What was the third one? Now in the same thing, you can also explain the pressure. I will include that as well. So here, under the same thing, pressure for gaseous reactants. So what happens there? When the pressure of gaseous reactants increases, the rate of reaction increases. So how does that happen? Here also we have already discussed this before. You can remember when you decrease the volume, the pressure of the reactants increases. So there again, the number of collisions in a unit time or per unit time increases. So because of that, the rate of reaction increases. So if we write that explanation, when the volume of the container is reduced, the pressure of gaseous reactants increases. Then the number of collisions per unit time increases. Therefore, the rate of reaction increases. So that again comes under the second factor. Concentration for solutions, pressure for gaseous reactants. Then what is the third factor? The third factor, that is the surface area. Area of physical nature. So here students, I am writing it according to the order of the factors that I wrote for the previous question. If you all have written it in a different order, accordingly you can explain. And it's not a must to have the explanation also in the same order. Why? Because we are specifying the factor again here. So it's just that to have a similarity, I am writing it in the same order. So whatever order you have used is fine. If we take surface area or the physical nature, you have a piece of calcium carbonate, you have calcium carbonate powder. What happens there? In calcium carbonate powder, the surface area is greater and it reacts faster with hydrochloric acid. So here we can say we can use a piece of reactant or powder of the reactant. When the reactant is used in the powder form, the rate of reaction is greater. That is, when the reactant is powdered, the surface area increases. So when the surface area increases, what happens? Again, the number of collisions between the reactant particles increases. Therefore, the number of collisions between reactant particles increases, and the rate of reaction reaction increases. So that is the explanation there. We have explained all three factors and how they affect the rate of reaction. If I go back to the answer, so the question was to briefly explain how each factor you stated above changes the rate of reaction. So under that first one, it's the temperature. So temperature, how does it affect? When temperature increases, the rate of reaction increases. When temperature increases, the kinetic energy of reactant particles increases. Therefore, the number of collisions in a unit time increases. That is why the rate of reaction increases. So that is the explanation for temperature there. Then we have the second factor, that is the concentration. Concentration, when concentration of reactants increase, the rate of reaction increases. That is again the relationship. So when the concentration increases, the number of reactants in a unit volume increases. Then the number of collisions, here also number of collisions in a unit time increases. Thus the rate of reaction increases. For the same factor, if we consider the gaseous reactants, then of course we need to consider the pressure for gaseous reactants. So when we say pressure, when the pressure of gaseous reactants increases, the rate of reaction increases. And there you can see, how do we increase the pressure? When the volume of the container is reduced, the pressure of gaseous reactants increases. Then the number of collisions per unit time increases. Therefore, the rate of reaction increases. So that is how pressure affects the rate of reaction of gaseous reactants. That is the pressure inside the container, not the pressure outside, pressure inside the container. Then the last factor that we discussed is the next factor, that is surface area or physical nature of reactants. We can use a piece of reactant or powder of the same reactant, the same mass in the piece form or the powder form. When the reactant is used in the powder form, the rate of reaction is greater. That is, when the reactant is powdered, the surface area increases. Therefore, what happens? Therefore, the number of collisions between reactant particles increases and the rate of reaction increases. So, you have a piece of reactant, you have a powdered reactant or smaller pieces, the surface area increases and then the number of collisions increases, and because of that the rate of reaction increases. So, that is how different factors affect the rate of reaction. Now, basically here we have discussed all the factors, how they increase the rate of reaction. You can also explain it in the opposite manner. When you decrease the temperature, how the rate of reaction decreases. That is also okay. But normally we explain it using increase in temperature and how it increases the rate of reaction, or increase in concentration and how that increases the rate of reaction. So, I am sure students, you all were able to answer this correctly by yourself as well. So, with that, I will move on to the next question. Question number 4. What is a catalyst? A substance that increases the rate of reaction without being chemically consumed is known as a catalyst. So, that is what you need to write here. A substance that increases the rate of a reaction without being chemically consumed is known as a catalyst. Known as a catalyst. A substance that increases the rate of a reaction without being chemically consumed is known as a catalyst. Then you all are familiar with the properties of catalyst also. You only need a small amount for the catalyst to increase the rate of reaction. And also the catalyst is specific to reactions as well as this part. They are not chemically used up, or their chemical properties don't change, but there can be physical changes. Say if you take it as a piece of catalyst, it can become powder. Because of the reaction taking place, there can be physical changes, but they cannot change chemically. They are not chemically consumed. There are no chemical changes taking place. So you all are familiar with catalyst. So that is the answer for the fourth question. Then I will move on to the next question. So question number 5. Equal masses of calcium carbonate chips and powder are separately reacted with equal volumes of dilute hydrochloric acid. Time taken and mass of calcium carbonate used up are given in the table below. So we have observed this reaction before, students. You all can remember, I did it in the lab also. Pieces of calcium carbonate or calcium carbonate chips and calcium carbonate powder. What is the reaction? Calcium carbonate with hydrochloric acid. What happens there? Calcium chloride, water, and evolving of carbon dioxide. So, is the reaction balanced? No, we have to balance it by putting a coefficient 2 in front of HCl. So, now the reaction is balanced. So, here you can observe the calcium carbonate dissolving, reacting with HCl, and also you can observe the releasing, evolving of carbon dioxide. So, there also we can see the rate of fizzing, as well as you can observe how much of calcium carbonate is used up. So, here we take equal masses of calcium carbonate chips and powder. Chips and powder. So, what is the factor they are trying to test? The surface area of reactants or the physical nature of reactants. You use chips and powder separately, and they use equal volumes of dilute hydrochloric acid. So, when you read the question, students, you all have to look at all these points. That's very important. And time taken and mass of calcium carbonate used up are given in the table below. So, here you can see time in minutes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They have observed up to 12 minutes. And mass of calcium carbonate used up, that is in grams. So, you can see chips and powder. Chips initially in the first minute 2.1 grams. Second minute 2.9 grams, then 3.5 grams. Fourth minute 3.9 grams, then 4.2 grams. So, you can see gradually the amount of calcium carbonate chips that are being used up is increasing. Then 4.5 grams, 4.6 grams, 4.7 grams, 4.8 grams, then 11 minutes also 4.8, 12 minutes also 4.8. So, when you are given data like this, students, you look at the values. Now, from the first minute up to the 10th minute, there is a change. That means more and more calcium carbonate chips are being consumed, used up. But thereafter, from this point onwards, you don't see any difference. That means the reaction is complete. All the calcium carbonate that you took, measured or weighed, here they haven't said how much, but you can see it's 4.8 grams. Those 4.8 grams have been used up. Thereafter, there is no reaction. Now, if we look at powder, first minutes itself, it's 3.1 grams compared to the chips. Chips 2.1, powder 3.1. So, there you can see the rate of reaction is faster. More substance is being used up. If you compare the other time intervals also, you can understand that. Second minute, 4 grams are used up. Third minute, 4.4 grams are used up. Whereas chips, it's only 3.5 grams. Then fifth minute, 4.7 grams. And the sixth minute itself, 4.8 grams have been used up. So we saw that they take equal masses. So here it took 10 minutes for the reaction to complete, but here you can see after 6 minutes itself, the mass is the same, 4.8 grams. So that means after 6 minutes, at the end of 6 minutes, the reaction is complete. So when you use chips, it took 10 minutes. When you use powder, it took 6 minutes. So from that itself, you can understand when you use powder, the rate of reaction is faster compared to using chips. You know the reason. When it is powder, the surface area of reactants is high. Because of that, the rate of the reaction is high. So the first question, draw the graphs for both instances above on the same grid. Use the same grid and you are supposed to draw the graph to show this change. The second one, in which instance is the rate of reaction higher? That of course we have already understood. When we use powder, the rate of reaction is higher. And third one, explain the reasons for the difference of rates of reaction in these two instances. So that also you know how you need to explain using the number of collisions in a unit time. So we will answer these 3 questions one by one. I will move on to the next slide and then I will answer these questions. So again, the table is given to you. I have explained this to you all already, how the mass of calcium carbonate changes with time. So we already saw when they use chips, it takes 10 minutes for the reaction to complete, and when we use powder, it takes only 6 minutes for the reactants to be completely used up. That is calcium carbonate. Now we have to use a grid to show the rate of change or draw the 2 graphs for the 2 instances. So how can we do that? Now I can use a line. So here I can draw this graph. Okay, students. So we need to mark the time. Here, of course, I will take 1.5 centimeters as 1 minute. So it's easy for me to mark it. You can mark it any way you want so that the graph, the grid is more clear to you all. So here 1, 2 minutes, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 minutes. So here it is going to be time in minutes. And then if we mark the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is how I have calibrated the x-axis, that is the time axis in minutes. Then we need to have the values for the mass of substance as well. Okay. So here we need to mark the values. Initially it's 0, then it starts from 2.1, it goes on to 4.8 grams. So maybe if I mark it up to 5 grams, 0 to 5 grams, then of course it is easy for us. So here it's 0. I will again take 2 centimeters as 1 gram. 2 4, 6, 8, 10. So that's going to be 1, 2, 3, 4, 5 grams. This is going to be the mass in grams. But there again, students, you can see we need to have 2.1, 2.9. I will mark those values as well. Then it's easy for us. 2.1, it's going to be this value, 2.1. Then we need 2.9. 2.9. Then we need 3.5. That's going to be here. Then 3.9 there. Then we need 4.2 here. 4.4. 4.2, 4.4, then there is 4.5, 4.6, there again the values are very close, then 4.7, 4.8, up to that only we need the values. So here students, when you all are drawing the graph, you can use the ruler easily. You all know what to do. You have to keep the points from both x and y axis. You have to get the coordinates, mark the points, and you need to draw the graph. So here also I will use broken lines in order to mark the points there. So first minute, here we need to have it for point 2.1. So here if I draw the other line, it's going to be up to this point there. Then the second one, 2.9, second minute. The second minute, it's going to be up to 2.9. So here you can see it has to come up to somewhere here and from here there. Then 3 minutes, you can see 3.5. So I have marked 3.5 there, then from there to here. Again, 4 minutes is 3.9. So we have marked 3.9 there, then here to 4 minutes. Then you can see students, 5 minutes is 4.2. 4.2 is somewhere here, and from there 5 minutes. Then if we are to mark 6 minutes, okay. So then 7 minutes you can see 4.5. So 4.5 is here. I have marked the point so you know the values. Then here it comes to this point. Then again you can see 8 minutes is 4.6. So 4.6 also I have marked here. These are very close values, students. Like I said, when you all are doing it in your writing book, it's more precisely you can do it. Then 9 minutes, 4.7. Here you can see. And then 10 minutes, it's going to be 4.8. That's going to continue. So here also 4.8. 11 minutes, it's going to be 4.8. 12 minutes also, it's going to be 4.8. So now, if I connect all the points there, here you can see the points, the coordinates have been marked. We have marked all the coordinates. You can see here, like I said, 0, 0, this is the point, then 1 minute 2.1 grams, then 2 minutes 2.9 grams, 3 minutes 4.5 grams, then 4 minutes 3.9 grams, 6 minutes 4.2 grams, 7 there is 4.5, then 8 4.6, 9 4.7 and 10, 11 and 12 also. 10, 11 and 12, all the points, it's the same value, 4.8 grams. So, 10, 11 and 12 minutes, it's the same value. Now, if we connect all the points, you will get the graph. So, here we can connect the points between all the different points there. Then this is a straight line. So, this is the shape of the graph. Again, students, when you all are connecting, you can connect it nicely so that you get a smooth curve. But here, this is what you need to understand from the graph. Now, at these points, can you see the gradient? It's increasing quickly. So, that means the rate of reaction is faster up to these points. Then as you go, as the time increases, you can see it's becoming more and more flat. So, that means the gradient decreases. The rate of reaction is slowing down. The rate is slowing down. The reaction is slowing down. And at this point, it does not change. So, that is for powder. So, this is for powder, calcium carbonate powder. The same way, we need to plot a graph. They have told us to plot both the graphs on the same grid. So, we need to plot a graph for calcium carbonate powder as well. So, for that, I will use a different color there to mark the points. We will maybe use red. I will use purple color. So, there also, you can see, students, 1 minute, it's 3.1 grams. So, it's supposed to be here 3.1 grams. So, you can see, students, it's faster. I'm not continuing the lines, but it's the same line there. Then for 2 minutes, it's 4. So, here it's 4, 2 minutes. Then we have the third minute. So, here 3 minutes, students, you can see 4.4. So, 3 minutes, of course, 4.4. That is 4, then 4.4. We have already. So, this is the point where we have the 4.4 mark. Then we have 4.6. 4 minutes, it's going to be 4.6. So, here of course 4.6 will be 4.6 is up to this point. Then thereafter 4.7 and after that it's all 4.8. So, 4.7 is here. 4.6 is there. Right. So, thereafter all the points are up to 4.8. Everything needs to go up to 4.8. So, now we don't need this graph. If I mark the points, first minute, it's this point, second minute 4, then here, this point, and thereafter it continues to remain at 4.8 itself. So, if I connect the points again, now this again you can see the change in graph up to here. So, then of course it becomes a flat line there. So, the black curve is for powder. So, here students, I have actually marked it wrong. It should be, this should have been the chips and the next one has to be powder. So, first one blue color is the chips and the black color curve is the powder. So, black color graph for powder and blue color graph for chips. So from the values also you all can easily see that. Here you can see with time. Now we have the time calibrated in the x-axis and the mass of calcium carbonate that is used up in grams in y-axis, and we have plotted the graph marking all the points there. Here you can see there should be other points also because it's going to be a flat line there. So immediately just by looking at the graph you all can easily understand when we use chips, that is the blue color curve, the rate is slower, whereas when we use powder the rate is faster. And also you can easily understand when we use chips the reaction completes at or after 10 minutes, whereas when we use powder the reaction completes in 6 minutes. So from all these observations and from the graph, it's even more easier to understand that when the surface area of reactant increases, the rate of reaction increases. And it is very clear when you plot the graph. I'm sure you all were also able to do it correctly. So that's the first question under this table. We will move on to the next question after this. So here, the second question, the same table is given to you all students. Second question, in which instance is the rate of reaction higher? That's obvious, no? In which instance? When calcium carbonate powder is used. Powder is used. So that is when the rate of reaction is higher. That is the answer to the second question. So with that, we will move on to the last part of this question. That is the third part. Again, here the table is given to you all students. Explain the reasons for the difference of rates of reaction in these two instances. So how will you explain it? When you have chips and when you have powder. Chips have only a certain number of reactant particles, that is calcium carbonate particles, exposed to or in contact with hydrochloric acid. Why? Because the surface area is less. But when you take powder, the surface area is more, there are more particles in contact with hydrochloric acid. So because of that, the number of collisions in a unit time increases when you use powdered calcium carbonate. And because of that, the rate of reaction is higher. So that is what you have to write here. So if you want, you can show it in a diagrammatic form, chips. So if you have chips, only the particles on the surface are in contact with HCl. So these are in contact with HCl. This is calcium carbonate. So here we can say when calcium carbonate is powdered, the surface area increases. Then the number of calcium carbonate particles in contact with HCl is higher. The number of collisions in a unit time increases. Therefore, the rate of reaction increases. So that is what happens there. When calcium carbonate is powdered, the surface area increases. then the number of calcium carbonate particles in contact with HCl is higher. There more particles are exposed. The surface is more exposed. So because of that, the number of collisions in a unit time increases, and therefore the rate of reaction increases. So that is what we can explain there. If it is the chips, only the surface is exposed to HCl. But when you powder it, more particles are exposed to HCl. So because of that, the number of collisions increases and the rate of reaction increases. So this is again another type of question, students, that you all need to answer. Although we did not draw any graphs when we discussed the lesson, now you are familiar with data related to rate of reactions and drawing graphs. So I am sure if you are given any question similar to this one, either they can give you the graph and ask questions based on that, or they can ask you to plot the graph and then ask questions based on that. You should be able to answer that. So with that, students, I have come to the end of this chapter where I discuss the questions given in your textbook. And in the next chapter, I will discuss some extra questions with you all.